Okay, so we're going to do a tutorial here on geometric series. So we're given a geometric series with the first term, which is 20, and that the common ratio is 7/8. Okay, so that's our parameters for our geometric series, and we need to find the infinite term of s, so what it actually sums to. The series sums to s to n, find the 12th one in the series, and the smallest value where the infinite term minus the nth term is a half. So where do we start? So find the infinite sum of the series. So to do that, what we need is first term divided by 1 minus the common ratio. So pretty straightforward question here. First term we know, common ratio we know, so let's just plug them in. So that equals 20 divided by 1 minus 7/8. Okay, 1 minus 7/8, that's 1/8. So 20 divided by 1 minus 8, bring the 8 to the top and multiply, that gives us 160. So the infinite term, 160. So that's what the series sums to. Okay, that's the first one. Now we find that the series sums to s to the n, and then find the 12th. So the s to the nth term is found by this way. So Sn equals, so it's 20 divided by 1 minus 7/8. So that stays. And then what we do is we multiply it by this term, 1 minus 7/8. And then let's just move that out of the way. And then what we do is we put that to the power of n. So just 7/8 to the power of n, and then that is separate. Okay, so that's what our formula is. So we can also break this down now that we know this. We know that 20 divided by 1 minus 7/8, that is 160. So we've got 160 times 1 minus 7/8 to the power of n, and that's it. So we want to find the 12th term. So therefore s of 12 equals 160 times 1 minus 7/8 to the power of 12. So let's type that into our calculator. 160 times 1 minus 7 to the 8 to the power of 12. So 127.77324. Okay, so 2 decimal places, let's just go to here. So therefore we get 127.77. That's our 12th term in the series. Now what we need to do is find s infinity minus Sn when it's less than a half. So let's just write that up here. S infinity minus Sn is less than a half. Okay, well S infinity, we know this already, that's 160. Subtracted from this formula here, which we now have, we've narrowed it down to this one. So if we put this one in, so that'd be 160 times 1 minus 7/8 to the power of n is less than a half. Okay. Object of this exercise is to get this n isolated. So let's start moving some of these numbers around and see if we can break it down. So first thing, I would suggest dividing by 160. That'd be a good start. So then we've got 1 minus 160 over 160, that's just 1. So 1 times all of this. So what we're going to get there is 1 minus 7/8 to the power of n is less than half divided by 160. So basically that's 160 times 2 in the denominator. So that would give us 1 over 320. Okay, let's get this 1 over the other side. So then we get minus 1 plus minus times a minus. So that will become plus 7 over 8 to the power of n is less than, so this will still stay, then bring the 1 over the other side, 1 over 320 minus this 1. That's this 1 here gone over here. This 1 here is just this 1. Okay, now we can get this 7/8 to the n isolated by bringing this 1 over to the other side. So that will leave us with 7 over 8 to the power of n is less than 1 over 320 minus 1. Minus 1 brought to this side means we're going to have to add 1 to each side. So then we just add 1. Okay, so minus 1 plus 1, that's these terms cancelled out. 7/8 to the n is less than 1 over 320. So if we use the law of logarithm, we can bring this n out front and then take logs of this and this. So that will bring us down to n times log 7 over 8 is less than log 1 over 320. Okay, right, now we're in a good position now. Divide both sides by log of 7 over 8, get n on its own. So therefore n is less than log of, let's write it over there, let's bring it over here, give us a bit more room. So divide both sides by log 7 over 8. Okay, so these will cancel out, not change the value of this formula at all. So therefore, let's just pull a line there. N is less than log 1 over 320 divided by log 7 over 8. Okay, let's type that into the calculator. So log 1 over 320 divided by log of 0.875, and we get 43.19823. So n is less than, so we still haven't got rid of this inequality here, 43.19 blah blah blah. Let's just put it all down. Okay, now we can't have a 43.19th term, we have to go up to the next whole number. So basically n would have to be equal to 44 to be our next whole number. So therefore what we can say is s infinity minus s 44 is less than 1/2. And that is our answer to this one here, where n equals 44. Okay.